In this lesson, we're going to look at how comparing rational numbers. And we're going to look at comparing rational numbers using symbols and also how to compare them by writing them in order from least to greatest and how we can do that using a number line. So first, let's look at how we compare rational numbers. So as we've learned previously, we've learned that when we were in elementary school, we took numbers like 10 and 13, and we said, which one is bigger? These are both positive rational numbers. Specifically, they're positive whole numbers. And it's easy to know that when we're counting, 10 came first, so 10 has to be less than 13. But what if we were comparing numbers like 3/4 and 75/100? They're in different formats, which makes it a little bit more difficult for us to figure out. So there's a couple ways that we could go ahead and we can compare these numbers. So one way is to go ahead and change them to the same format. So they're both rational numbers because it's possible to write this number 0.75 or 75/100 as a fraction. So therefore, it's a rational number. 3/4 is less than that, equal to it, or greater than it. So we can go ahead and we could take 75/100 and we could write it as a fraction using place value and then reduce. Well, 75 is divisible by 25 and so is 100. Therefore, I get 3/4. And now, if I'm going ahead and comparing the two, I know that 3/4 is the same as 3/4. What about a percentage? Let's say I had 20%, and I want to know, is it greater than, less than, or equal to 1/7? Well, we know that to take a percent and change it to a decimal, it really means 20 out of 100, or 20 hundredths, which means it's 0.20, or just 0 and 2/10. A fraction, to make it into a decimal, I need it to have a denominator that's a multiple of 10. 10, 100, 1,000, etc. But 7 doesn't go into those numbers. So the other way to do it is to use division, remembering that the numerator is our dividend, the denominator is our divisor. We would do long division. 7 goes into 10 once, with 3 left over, bring down a 0. 7 goes into 30 4 times. 4 times 7 is 28. Now, I actually have enough information to make a comparison, and that's because I know that 20% is exactly the same as 20 hundredths, but 1/7 is approximately 0 and 14 hundredths and a little bit more. But I can now look at the tens place and I can see that the number from 20% has a larger value in the tens place than 1/7 does. Therefore, 20% has to be greater than 1/7. So when I'm comparing rational numbers, one of the things I need to do is assure that they are in the same format. So I want to compare decimals to decimals and fractions to fractions. Okay, so now let's go ahead and look at comparing two negative numbers. So what if I had the number -5 and I wanted to compare it to -11? Well, we know they're not equal to each other, but is -5 greater or is -5 less than? Well, if we think about that number line, and I went to -5, and then I went to -11, -11 is farther away from 0, therefore it has to be much less than 0 than -5 is. So -5 is the greater one. So it's kind of backwards when we're dealing with negative ones. The closer it is to 0, the greater that it is. So if I was comparing 3 and 5/10 to negative 3 and 42/100, how would I compare those? Well, if I was looking at a number line, here's 0, and here's negative 4, there's negative 2, and there's negative 3. Well, I would have to get to negative 3, and then I would keep going, and negative 3 and 4/10 would be before negative 3 and 5/10. Therefore, this is my greater value. So I would use a symbol that negative 3 and 5/10 is less than negative 3 and 42/100. And so when we think about it, this has a greater magnitude or size of negativity than negative 3 and 42/100. So when we're comparing negative numbers, the one with a greater absolute value is usually or is always going to be smaller. Now, if they have different signs, negative 2 compared to 5, for example, how do I compare them? Well, on a number line, here's 0. This is all the positive numbers. This is all the negative numbers. Anytime we have a positive number, it's always going to be greater. So negative 2 definitely has to be less than 5. And if we went ahead and we compared negative 1/4 to 5/8, I don't even need to have a common denominator to compare these fractions. I can just go ahead and say, because this is negative, it has to be less than 5/8. Just like 1 and 2/3 versus negative 10 and 5/7, which one has to be greater? The positive one. So comparing negatives and positives is always a pretty easy job. Now let's go ahead and look at ordering rational numbers. So these are examples of rational numbers. A rational number, remember, is any number that can be written as a fraction. They could be negative, they could be positive, or they could be this number, 0, which is neutral. So here's a tip. When we're trying to write these in order, first we have to have an order course, and we're going to do least to greatest. We could do greatest to least, but this is which one we're going to do. So first, group the numbers by signs. What does that mean? It means find your negatives, because we know that negatives are going to be less than all of the positives, including the neutral number 0. So we know 0 definitely has to be in the middle, separating the positives and the negatives. And all the negatives, we learned in elementary school how to order those numbers. So let's go ahead and order the 0 and the positive numbers first. So we know 0 is the least. Okay, 1/4 is less than 1. So 1 is definitely bigger than that. 2 is definitely bigger than 1. 23/5, well, it's kind of hard to compare, but could we make it a mixed number? Yeah. 5 goes into 23 4 times, with 3 left over out of 5. So that means it's bigger than 2. 6 is definitely bigger than 4 3/5. And 4 1/2, well, that's another one that's hard to compare. Well, if 4 5/10 is the same as 4 1/2, and I know that 3/5 is bigger than a half, therefore, this one has to be less than 4 3/5. And next we have 2 1/10, and 2 1/10 is bigger than 2. So now I think we have enough information. So we know 1/4 was next, then 1, then 2, then 2 1/10, and I'm going to go ahead and mark all the ones that we've used already. So now I have 23/5, 6 4/5, and we knew that 4 1/2 was less than 23/5. So we know that 4 5/10 is less than 23/5. And notice I'm using the native notation, or the original way we wrote the numbers. Okay, so we've done this one, we've done this one, and the last positive number to use is 6. So now we're ready to do the negatives. Now remember we said the bigger the magnitude of negativity, the the smaller it is. So we want the most negative number we know is going to be the least. The one closest to 0 is going to go exactly to the left of 0. So which one is closer to 0? So when I'm looking at the negative numbers, I want to go ahead and I want to look at the ones closest to 0 first. Well, I know -1 is definitely less than 0, but there's some numbers that are between -1 and 0, and that's that 6/10 that's negative and the 1/2 that's negative. Well, which one's bigger? Well, if I make 6/10 a fraction, I know 5 out of 10 is exactly half, which means this is a little less than a half, which means -1/2 is closer to 0 than -6/10. So I've done this one, I've done this one, and now I have left over -4, -3 3/5, -4 1/10, -5. So which one is the one closest to -6/10 from there? Well, it has to be -1. And then next would be one of those two. Which one? Well, -3 3/5 would come before -4. So we have -3 3/5, -4, and then, oops, not negative. Then we have -4 1/10, and then we have -5. So the numbers in order from least to greatest would be -5, -4 1/10, -4, etc. So why do we need to bother with comparing numbers at all? Well, it helps us make decisions. So let's suppose that we were in Alaska. So here's my friend Iggy, who lives in Alaska, and they were keeping track of the temperatures and figured out that yesterday the temperature was -10 degrees. Well, if I go on a number line, here's 0, I'm going back, and here's -10. And then the next day, the temperature's -15 degrees Celsius. Well, which one is the furthest away from 0? Well, -10, then -15. So if my question was, is today's temperature higher or lower? Well, I would know that it was the temperature that was -15 degrees because it's farther away from 0. So that means today's temperature was lower than yesterday's, and specifically by 5 degrees. So if I was to write that symbolically, I'm comparing -10 to -15. Was -10 greater than, equal to, or less than -15? Well, we figured out that it was greater than -15. And so comparing numbers helps us make decisions. So here's another one that we would say. Suppose you saved your money and you were going to buy some new shoes. And you found that 2 stores have them on sale. One says a third off, and the other one says 30% off. Well, which one is going to save me the most money if the price was the same to begin with? So let's see. We know that we can't compare a fraction to a percent because they're not in the same format. So if I go ahead and I make them both decimals, for example, I would do 1 divided by 3. And through the magic, we know that it gives us 3 repeating. Okay, so it's 0.333, and the 3 repeats and repeats and repeats. Versus 30%, we know is 30 out of 100, which is the same as 0.30. And so if I compare them, so which one is bigger? Well, 33 hundredths, even though that's repeating, is bigger for sure than 30 hundredths. Therefore, we know which one is greater. It has to be that 1/3 is greater because when they're both written as decimals, we know that 3 repeating is greater than 30 out of 100. Therefore, where am I going to get the biggest discount? At the store that says it's 1/3 off. So even though in their formats, 1/3 looks like it's less than 30%, because 1/3 is less than 30. But when we think about the meaning of these rational numbers, because we're putting them in the same format or notation, it helps us to compare them. And we make a decision because we save us a little bit more money. Hope this helps. Thanks.